Hi, and thanks for joining us again today for another great video from PEBKAC University. Today we're going to be discussing a little bit about how to calculate actual memory usage on a Linux system. Now, the reason for this is because I hear from a lot of people that they have different tools from various vendors, be it monitoring tools, security tools, things that are based on Linux, have a Linux backend that they can access, whether it's direct console access or access through an SSH connection. And some of these tools, they have a web-based front end that the vendor typically expects you to manage everything from. And sometimes they include their own little monitoring or health software, which will give you things like disk space usage, CPU usage, or even memory usage over a period of time. Maybe it's included as part of an RRD graph, maybe 5-minute bucket intervals. And a lot of times, what will happen is you may not be able to see under the hood of what's happening with that particular health check. You don't know what formulas are being used to give you the result. And sometimes it's good to be able to double check that to make sure it's accurate. And today we're going to focus on memory utilization. Because we've all seen it. You have some tool that runs its health check and comes back and tells you that the system is using 90+% of the system memory and throwing you a critical alert. Now the question is it really using almost all of the system memory? Do you really need to be concerned at this point and circling your wagons and calling up vendors and figuring out, oh no, what's consuming all my memory? What can I do? Um, and what I'm going to show you today is how to actually calculate that yourself and make sure that what you're getting is accurate information from your vendor tool. Okay, as you can see here, I've opened a PuTTY session into one of my virtual Linux machines. This one is actually my snort machine. Um, some people also prefer to use the free command in Linux to get these values. You're more than welcome to do that. I just prefer to run top. And I've actually quit out of top, so you'll see it's not updating anymore. I just wanted to get a quick snapshot. And what I'm really concerned with is everything starting here with the mem column. And the way this is laid out is basically total physical memory. In this case, it's roughly 4 gigs. Used physical memory, free physical memory, and finally we have the buffers. On the swap line, we've got our total amount of swap space. In this case, it's roughly 2 gigs. Not using any swap space here. Amount of free swap space. Obviously, since we're not using any, this is equal to the total amount of swap space. And finally, the cached line. And cached is basically just the disk cache. If you have a memory sitting up here, physical memory sitting up here in the free column, your Linux system is smart enough to pull some of that available memory into the disk cache. And the disk cache is used to hold information or data for processes that frequently access that data. If it's data that's constantly accessed by a process, it puts it in the disk cache. And what that does is when the process needs that data again, the normal process would be to read that data from your disk, which is not the most efficient way to do it. So once it's been read and it's in memory, it can be stored in the disk cache and accessed from there. So process, say you have a process that's looking for some specific data, it checks the disk cache first. Because if it finds the data it needs there, it's going to read it out so much faster than if it actually has to go and read it from the physical disk. If it's not there, then it just reads it from the disk anyway. So there's really nothing lost, nothing in time, but only a gain if it's in the disk cache. So it's really a smart usage of available memory, or free memory. And with that said, any process that needs cached memory can request it and will get it, as long as there's cached memory available. So basically, cached memory is available memory. So if you have plenty of memory here and almost nothing in the free column, then you're not out of memory. You still have plenty to go. No worries there. As you see, I really just powered up very recently this virtual machine, and it's not a busy system. It's in a test lab, so it's not really using much memory at all. But if you have a system that you're getting reports that it's using 98% of the memory, you can still use the formulas I'm going to show you, and you may see a bigger impact than what we're going to see here. And what I've typed in here into this Google search blank, I'm not actually going to do a search here, but I wanted to just share with you the formula that I use for memory calculation on a Linux system. And what this does is gives you the percentage of memory that's used. And what it is basically take the values from the top or the free output. I take the physical used memory, add it to the swap used. From that, we subtract the buffers plus the cached and divide it by the total physical memory plus the total swap and multiply it by 100 to give us our nice percentage. Now, I've taken values from the PuTTY session that I just had opened up from my Linux system, and what I've done is I've taken just the physical used memory, and I plugged in the wrong value here, so I'm going to swap that out. So it's the physical used divided by the total physical times 100 to give us our percentage. So we'll see this system is using roughly 27% of its physical memory. We're not accounting for swap space at this point. We're not accounting for cached memory. If we only focused on the physical memory, we would see that 27% of it's being used. Not a lot, not really a need for concern, but I wanted to show this because this is what I found happens in a lot of cases. You have your tool which calculates memory, but you don't know how it's doing it. It may be doing this, which, if you remember how I talked about free physical memory getting allocated to the disk cache, well, that cache memory is still available. But if you're only looking at physical total and physical used, when that memory is added to the disk cache, the amount of used memory is going to go up, and free is going to deplete. So it'll look like you're almost out of memory, when in fact the cache is available. And there's no problem. So looking at physical memory, if you find there's a high value, obviously this one isn't, but if you find a high value like 80 or 90% of the memory being used with this calculation, then it's time to do this. And this is the formula I've come up with that is a much more accurate representation of how much memory is being used. And typically, if this is high, around 90+%, then maybe there's an issue. But as you'll see, even on this system that's not using very much memory. Physical only calculation, we have 27% used. Let's factor in things like swap space, buffers and cache, and see what our percentage is. And it's about 15. So if I were looking at physical only, I'd be about 27% used. Doing a more accurate calculation that includes swap space and buffers and cache, so it tells me I'm only using around 15% of the memory. So I've got 85% memory available on this system, so there's really not an issue there. And again, it may not be as big of a deal on this system that's not using very much memory, but on a system where this calculation here shows you 99% and this one shows you 60, it gives you some breathing room. It lets you know you can relax, that the system's fine, it's not out of memory. You can, go to your manager, your boss, and tell them, that report that you got from your tool is not accurate, and that there really is no issue at the time. And then you can go back to relaxing a little bit. I hope you found this video useful. I've got a lot more things in the works, more videos in our Snort series, more quick little tech tips like this one. So stay tuned, subscribe to this channel, and look forward to what we have next. Thanks.